Okay, we're in chapter 16. We're in the home stretch of Algebra 2. Just about 4 more lessons and we're done with the book. So, today we're doing permutations and combinations. Everybody's favorite. Y'all seem to hate probability. It's not that bad. Just remember this. Permutation, order matters. Combination, order doesn't matter. So that's what you have to ask yourself when you're reading the question. Simply ask, does order matter here? Yes, permutation. No, combination. Now, down below, I know Jack's probably getting hungry looking at all that, but you have a combo meal all the time. See, you get it? It doesn't matter what order they put the stuff in, as long as you get your combo meal number 3, which is quarter pounder, large fry, and a Coke. You don't care what order they put it in the bag, just as long as you get all 3. Combo meal. All right, to do a little review, NPR and NCR stand for permutation and combination. Mathematically, the formulas are as follows. You probably learned these in 8th grade, but the beauty is now on your calculator. If you go into math and then over to probability, you have NPR and NCR on your calculator. But let's just do it the long way. Say you had to figure out 7p3. If we do the math behind it, this is what it means. It means that I had a total of 7 objects to pick from. And I was only allowed to pick 3. Up top is 7 factorial. And on the bottom is 7 minus 3 factorial. And factorials, you remember, multiply out, decreasing by 1, all the way down to 1. 4, 3, 2, 1 cancels out with 4, 3, 2, 1, and I'm left with 210. Now, a combination of 7C3 still means I get to pick 7 objects, to pick from 7 objects, and I get to keep 3. It looks almost the same, except it's got this little extra part right here. And that's because a combination will divide out what it deems the same. So in other words, a permutation, let's say we had the letters A, B, C. And then we mixed them up and wrote B, A, C. And then C, A, B. A permutation would look at all of these as different because order matters. A combination says, chill out. What's the difference between A, B, C, B, A, C, C, A, B? They're all the same 3 letters. So a combination is dividing out over here what it sees as the same because it thinks it's no big deal. So you're going to get a smaller answer with combinations than permutations. So again, 4, 3, 2, 1 cancels out with 4, 3, 2, 1. But now 3, 2, 1, which is 6, will cancel out with this 6, and it will see only 35 different combinations. All right, so here we are with some problems. Find the number of different ways the letter of softball can be arranged. So you have to ask yourself, does order matter when I'm writing letters? Yeah, it's called reading. Order does matter. So, all right, it's a permutation. Figured that out. How many letters do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I'm choosing from 8 letters. Well, how many of them am I using? All 8. So 8P8, if I came over here, and I have to put in my 8 first, I get 40,300 320. But wait a second, there is just a little bit of a trick to this one because it's algebra 2. You see how L and L are the same? So if I wrote this word, and then Megan came up to me and said, well, I'm going to write a different word. I said, Megan, you wrote the same word as me. And she said, no, I didn't. I switched these L's. Well, now, cranky old permutation, you can't tell the difference between switching the L's. So I have to divide out by how many repeat. 2 letters repeat, so I'm dividing out by 2 factorial. So the real answer here is 20,160. And that's the big thing today. We have to divide out the repeaters. Algebra 2 loves to give you permutation, but they kick it up a notch in 11th grade by making you divide out repeaters. Okay, the number of ways 10 people can stand on an Olympic medal stand. Question 1. Does order matter? Absolutely. So it's a permutation. I'm picking from 10 people, and there's only 3 places on a medal stand. Gold, silver, bronze. Or another way to look at it, and this is how I do my permutations, I've got 3 places. 10 people are vying for the gold, 9 people then vie for the silver, and the final 8 fight it out for the bronze, getting me 720. And you get that same answer if you did 10p3 on your calculator. Now I have to ask myself, are there anybody repeating? No, everybody's an individual. There are no repeaters in this, so I don't have to divide out anything. Excellent. Number of ways you can stack 3 pennies, 2 dimes, 4 quarters. Does order matter? Yes, order matters here. So it's a permutation. So I have 3, 5, 9 different objects that I'm stacking. (9p9), or you can do 9 factorial. Do I have any repeaters? Things that I can't tell the difference between if I switch their places. Yeah, pennies. Dimes. And quarters. Or another easier way to write that, 3 factorial, 2 factorial, and 4 factorial. Again, you can take out the calculator to figure this out, but by doing it factorial way, this is what I see. Give myself a little room right here. I see 9 factorial is 9, 8, 7, 6, 5. And then I'm going to stop at 4 factorial. Why? Because I have a 4 factorial here on the bottom. They're going to cancel out. 3 factorial and 2 factorial. Well, 3 times 2 times 1 is 6. That crosses off with that. 2 times 1 is 2, so we'll put 2 into 8 here and get 4. So now I have a lot easier to multiply on my calculator. 9 times 4 is 36. 36 times 35. That's what it boiled down to. 36 times 35. So there was 1,260 different ways to stack all these. So you're asking, when does a combination come in? Well, here it is. Our last problem will be a combination. You have to choose a student council. There are 10 boys who are running for student council and 8 girls. There are only 5 seats on the council. How many different ways can you select 3 girls and 2 boys? Does it matter if you choose a boy first to get on the council? No. So this is a combination. So I need to select 3 girls. I'm comboing it, and there are 8 girls to choose from, and I need to choose 3. And I'm going to come back to that in 1 second. 2 boys. Well, there are 2 boys, and I'm choosing from 10. Now, if you remember, and in probability means to multiply. It does not mean to add. It's backwards in probability. So 8 C3 times 10 C2 gets me 2,520 ways to select 3 girls and 2 boys from that pool. How many ways can you select all boys? So, well, I got 10 boys to pick from, and I want all of them, all 5 seats, to be boys. 10 C5. There's 252 ways. How many ways can you be all girls? Well, I think you got it by now. I only have girls to pick from, and I've got to pick 5. I'm going to just re-grab up here so I don't have to go into math again. 8 C5. There's only 56 ways. Okay, done.